Okay, so in this Carnival Ride, we have a person being able to stand on a wall. It doesn't matter what they ask us to do, the problem is always the same. The steps that we're going to follow are the same. So the first thing is identify the forces we have. The first force we have is the force due to gravity down. We have the normal force from the wall to the person, and this force is towards the right. And if I use the, let's do the free body diagram. All right, so the center of the circle is here. So this person moves around like this, right? So the radial axis, the axis that will go through the person in the circle, should be what we know as horizontal axis. This is the radial. The y-axis will be the perpendicular one, and this is the person. So the forces on the person are the force due to gravity Fg equals mass times the acceleration due to gravity. We have the normal force, and the normal force is, okay, so the normal force is to the right because the person is stuck on the wall, right? As soon as this starts moving, the person is stuck on the wall. Why is that? Because by pushing the wall pushes back and creates the force that we want in order to have a centripetal force. So the normal force is to the right, and apparently some force cancels out gravity, and that's friction. So we have friction, and we have actually static friction. It doesn't move. If it's going to move, it's going to fall down. So the rubbing is here. Always remember that the friction is always parallel to the motion, is parallel to the surface, and the surface is perpendicular now. Well, the normal force is perpendicular to the wall, so it's to the right. This is the free body diagram, the radial axis, the y-axis. So apparently the forces on the radial axis should create the centripetal force, meaning that the sum of forces on the radial axis should create the centripetal force mv squared over r, where the mass is the mass of the object doing the circular motion, the person. The velocity is the velocity the person has, the speed it has, and r is the radius of the wall. Now the sum of forces on the y-axis should be 0. We see no motion up or down. So the normal force equals mass times velocity over radius. Well, the friction will be equal to the force due to gravity. And there's one more equation we always have, is the equation for friction, definition of friction. Friction is the coefficient of friction times the normal force. That's the relationship that connects the two axes. This is the equation that connects them always. This is always what is going on. Remember, normal force is always perpendicular to the surface. Friction is always parallel. Friction and normal force are never in the same axis, never. And this formula connects the two axes. So by doing so, by combining these three equations, what do we have? So we have that friction, which is mass times g, equals the coefficient due to gravity ms times the normal force, which is mass times velocity over the radius. We can get rid of the mass, so we find that g equals the coefficient v squared over r. So this is the formula we have. Now, they can either give us the speed and the radius and ask for the coefficient, or give the coefficient and the radius and ask for velocity, or give velocity and coefficient and ask for the radius. What is important is that we see that the velocity this ride has nothing to do with the mass. No matter what the mass of this person is, the speed this is going to turn around has nothing to do with the mass. Doesn't matter. So this is the formula, and from this point on, depending on what we know, we can solve for velocity or for radius or for the coefficient of friction m.